Hi students, this is Meenakshi, Assistant Professor, Rohini College of Engineering and Technology. We are going to see the course Network Security and the topic is Wireless Network Security. The objectives are to learn about the basics of wireless network security and to know about IEEE 802.11i. So 802.11 Wireless LAN Security. So what is the main difference between wired and wireless LAN? Okay. So wireless traffic can be monitored by any radio in range. So here the devices need not be physically connected. Whereas in wired network, all the devices should be physically connected. So in wireless, the devices need not be physically connected. So it can be monitored by any radio in range. So we need a strong security, that is robust security services and mechanisms for wireless LANs. For privacy, 802.11 defined the standard wired equivalent privacy, that is WEP algorithm. But in this, we have several drawbacks. So in order to accelerate the introduction of strong security into the wireless LAN, so we have WPA, that is Wi-Fi Protected Access. So what is WPA means? It is a set of security mechanism. So it is used to overcome the major drawbacks in the previous cases. And the final form of 802.11i. So this standard is referred as Robust Security Network. So what are all the RSN services and protocol? So the services are access control, authentication and key generation, confidentiality, data origin authentication, integrity and replay protection. So for that, we are using the protocol IEEE 802.1 port-based access control for providing access control service. Similarly, EAP, that is Extensible Authentication Protocol, for providing authentication service and key generation service. Then TKIP and CCMP for providing services confidentiality, data origin authentication, integrity and replay protection. So IEEE 802.11i RSN. So this security specification defines the services. So as I told earlier, the services are authentication, access control, privacy with message integrity. What all the cryptographic algorithms are used in 802.11i means? So to provide confidentiality, we can use RC4, AES, and for providing integrity and data origin authentication, you may go with HMAC MD5 or HMAC SHA. And for key generation, you can go with HMAC SHA or RFC 1750. So these are the cryptographic algorithms we have used in IEEE 802.11i. So the operation of IEEE 802.11i, so it can be broken down into 5 distinct phases. And one more thing, here one new component called authentication server is also included. So what are the 5 phases means? Discovery, authentication, key generation and distribution, protected data transfer, and connection termination. So these are the phases of operation. So the first phase is discovery. It is between station and access point. Then authentication happens between station and authentication server via the access point. Then key management, that is sharing of keys. So it has happened between station and authentication server through the access point. Then the fourth phase is protected data transfer, that is data transfer between the station and the end station. But here the encryption is done only at the end station and access point. Okay. So it does not provide end-to-end encryption. And the final one is connection termination. So the first phase is discovery. So the access point uses the messages called beacons and probe responses to advertise it is having IEEE 802.11i security policy. So any station, so they can use these beacon signals to identify a particular access point to which they want to communicate. Once the access point is identified, the station associate with the corresponding access point and they can select their cipher suit and authentication mechanism. So what is authentication? So as I told, station and authentication server both exchanges their identities to each other through access point. Okay. So access point blocks any non-authentication traffic between station and authentication server. Once the authentication is successful, then it allows the packet to transfer. Access point does not participate in the authentication transaction. Only it just forwards the traffic between station and authentication server. So authentication server is responsible for doing authentication. Then third phase is key generation and distribution. So the access point and the station can perform several operations through which they can exchange cryptographic keys, and the keys are placed on AP and station, and the frames are exchanged between the access point and the station. The fourth phase is protected data transfer. So here the frames are exchanged between the station and the end station, but via the access point. As I told already, the encryption is not provided end-to-end. And the final phase is connection termination. So during this phase, the connection is closed and the connection is restored to the original state. So with this, we are concluding the operation, that is the phases of IEEE 802.11i. Then we move on to IEEE 802.1x access control approach. So here we have two concepts, controlled port and uncontrolled port. Okay, so what is this? So IEEE 802.11i uses EAP, that is Extensible Authentication Protocol. So it is mainly used to provide access control functions. So once the supplicant is nothing but a wireless station. So once the supplicant is authenticated by the authentication server, so you can use any authentication protocol for authentication. So once it is successful, once authentication is successful, the authentication, that is the authenticator, that is AP, only passes control or authentication messages between the supplicant and the AS. If the authentication is not completed, then it does not allow the supplicant to transfer the data. Okay. Until then, the port is blocked. Once the supplicant is authenticated and the keys are provided, then authenticator forward the data from the supplicant to the authentication server. So as I told, here we have two ports, controlled port and uncontrolled port. So we all know ports are nothing but they are the logical entities. They are defined within the authenticator. So here the authenticator is nothing but the access point and they refer to the physical network connection. Okay. So wireless LAN, the authenticator is having two physical ports. One is to the distributed system and the other one is to wireless communication within BSS. That is this one and this one. So then we move on to IEEE 802.11i protected data transfer phase. So here we have used two schemes for protecting our data. One is TKIP and the other one is CCMP, that is temporal key integrity protocol, and a counter mode CBC MAC protocol. So they are the two schemes which are used to provide protected data transfer service. Okay. So with this, I'm concluding the topic. Thank you.